Well, good evening and welcome to Kopernik Observatory. It's great to have you here this evening. We also want to welcome those on the live stream that are watching. And in fact, what we'll do for the people on the live stream, we will we got to get everybody to say hello. So everybody, start waving to the people on the live stream. All right. Well, it's great to see a number of familiar faces, and but also a couple of new faces. For those that are new, my name is Drew Desker. I'm the director here, and every Friday from March to mid-December, we offer public programs here, and it's not always about astronomy, although we have a little bit of astronomy tonight, and then some not astronomy, and but again, I'm trying to think for those people that I guess, is anybody new here who's never been here before? Everybody's been here before. All right, great. So then we'll skip most of the standard welcome newcomer banter, and but I do want to let you know about things that are coming up over the next couple of weeks. Tomorrow, actually, we have an opportunity to sort of have you prepare for the next lunar eclipse. There's a lunar eclipse that will be happening in November. What's the date again? November 8th. It's going to be a deep into the evening kind of an eclipse, but Jeremy Carty, our live stream astronomer, will tomorrow evening at 8 o'clock is going to do a sort of a preview of that eclipse, but also while he's doing that, actually give you some tips on how you might actually shoot the moon, how might you actually photograph the moon. So so it'll be a combination of telling you what the eclipse is going to be like, but also giving you some tips and tricks on how you might shoot the eclipse for yourself at home. Then next Friday we've got a talk by Adam Flint. We'll be talking about effective heating and ventilation systems. In fact, actually, we are literally in the middle of, for those of you that came in here, you may have noticed some of the ceiling tiles missing, and we are literally in the middle of changing our entire HVAC system to an air-to-air heat pump system. So actually, Adam will be talking about why those things are so efficient and why it's if you're in a position where you need to change your heating system, it's certainly something to consider. And then at the end of the month, we're having our second annual Hocus Focus. This is going to be sort of a Halloween-themed event where families will come through, do various activities that have sort of a Halloween-ish kind of a slant to it, and we may even set up our planetarium with some sort of Halloween-based star tour, and so that's coming up at the end of October, and we will actually be opening registration. Those will actually, you'll need to register for tickets for our when we started announcing that we wanted to do this, we got something like over 1,000 people interested. We can't accommodate 1,000 people, so we're going to have a 6 o'clock, a 7 o'clock, and an 8 o'clock cohort or seating, or for whatever you want to call it. But anyway, let's move into our topic here. This is the second time, Gil, that you have spoken here, I believe.
Yeah, I think so. It was quite a few years ago.
Yeah, quite a few years ago. And not too many people have actually been able to, say that they've been on all continents. And Gil, I'm assuming you have.
I missed one.
You missed one. Okay. Well, you got one more on your bucket list then, I guess. But Antarctica is an interesting place, and it poses some interesting challenges for scientists and people who work down there. But it's also an interesting place that you can do things there that you can't do anywhere else in the world. And so we're fortunate that Gil earlier this summer happened to be up here for a Friday night and said, hey, I'm still around. So if you want me to do a presentation, and I say, let's make it happen. So, Gil, I'm going to turn it over to you. Thank you.
I'm Gil, and I'm glad to be here tonight. And I thank you all for coming. Talk a little bit about space weather and working in Antarctica. Not too technical. I'm going to stay away from a lot of technical things. At the beginning, there's a little bit of it with space weather, but then when I get into Antarctica, the text goes away, and my voice just keeps going and going and going. So first off, two things up here. You see NJIT up in the left corner. That's New Jersey Institute of Technology. I work there as a research engineer. I used to be a research scientist, but for them I work as a research engineer. And you see NSF, which is National Science Foundation in the lower left corner. They fund, basically through grants, research in Antarctica. So New Jersey Institute of Technology, I'm not going to go through all this, but as you can see, these items on the screen here are just some of the things they do that have to do with space weather. The last three are the only things that I work on. Basically, the instrumentation in the South Pole, McMurdo, which is on the shore, and deep field observatories, which are called AGOs, Automatic Geophysical Observatories. So what is space weather? Well, you can think of space weather as basically the interaction of the sun and the earth and everything in between. What does the sun do? How does it influence the earth? That's really what space weather is, trying to determine exactly how that works. Now it gets a little bit more complicated when you take a look at what the sun is like, what the sun does. Sun emits electromagnetic radiation. Lights that you're seeing now is electromagnetic radiation. Wi-Fi is electromagnetic radiation. Everything that you basically think of, from gamma rays, X-rays, all the way through to radio waves, all electromagnetic radiation. So when the sun emits it emits it at the speed of light. Basically, it comes to Earth. So whatever happens on the sun, when it's electromagnetic radiation, it basically hits us about 8.5 minutes later. So just the speed of light takes 8.5 minutes to get here. So you could think it's impossible to happen, but if the sun just disappeared, it'd be 8.5 minutes before we knew about it. And then we wouldn't know about anything else. And then the sun also emits electrically charged particles. So basically, it's not just the radiation, it also emits particles. Those particles do not travel at the speed of light. They travel somewhere between 100,000 to a couple million miles an hour, depending on what's going on. And they can take days before they get to Earth. Now, the two a little bit interact with each other, and as a result, you'll get the electrically charged particles when something happens that emits that electromagnetic radiation. So you can watch the radiation and get an idea what may be coming with the charged particles, because they're the ones that really affect us a lot. And they're known as coronal mass ejections. So here you can see a little bit on the screen. The sun is putting out the radiation, and then that weird-looking thing at the Earth is basically the bow shock wave pushing the magnetosphere, the Earth's magnetic field, out into a tail. And that tail goes out to almost 4 million miles in back of the Earth. Here's a little bit more, well, much more detailed view of it, also showing the radiation belts, Van Allen radiation belts, solar wind coming in. If it wasn't for our magnetosphere, we couldn't live on Earth. That's one of the problems with going to Mars, is the radiation. If we had a bad solar storm when an astronaut was out on a spacewalk, it could actually kill them. We'd have the same problem on Earth if we did not have a magnetosphere to basically deflect that radiation away. You can also see the two areas there, the cusps, basically the little white lines. Basically, that goes to the south and north magnetic pole, and that's where the radiation can come into the Earth. And that's basically where we get our aurora from. That's where we do a lot of measurements because of that. Again, that magnetotail extends out a long, long way away. The Earth's atmosphere is only about 100 kilometers thick, so it's really a really thin sheet of atmosphere around us. It's the magnetosphere that really protects us from that radiation. If you look at the Earth's magnetic field without taking into account the sun, it's actually really simple. It's almost like a bar magnet. You probably, some of you have tried in grade school or whatever, putting a bar magnet on a table and sprinkling iron filings. You end up with lines that look much like this, just lines around it. That's exactly what happens with the Earth's magnetic field. It is perturbed a lot by the sun, though. Our Earth's magnetic field actually flips north to south and south to north, typically every 200 to 300,000 years, although we're a bit overdue. It's been about 780,000 years since that last happened, so we're kind of outside the window where it usually does happen. And when it does flip, it's not instant. It takes about 7,000 years to flip around. So the animals like whales and pigeons and whatever else rely on magnetic fields for their navigation have plenty of time to adjust to the flip. One of the things, though, is when it does flip, it's not looking so much like a bar magnet. It gets pretty perturbed. A lot of weird things happen with the Earth's magnetic field as it's going through that flip north to south, south to north. The sun's magnetic field, on the other hand, is quite a bit different. It is very convoluted. It is very dynamic. It's very complex at the surface. And the poles flip there about every 11 years, almost like clockwork. It's plus or minus, but typically 11 years. And that's what we call the solar cycle. If you take a look at the sun magnetic field, it looks nothing like the Earth, nothing like a bar magnet. Very confusing, very convoluted. What types of solar activity do you look at? Well, these pictures I took on Monday because that's when I put this together. So they're not quite up to date, but they're pretty darn close. There's sunspots. A lot of you heard of sunspots. There's dark areas on the sun, little patches of dark areas. And they can be as small as 10 miles to as large as 100,000 miles in diameter. They look black. They're very hot. They look black because they're not as hot as the rest of the sun, the rest of the surface of the sun. And it's a localized disturbance causes them. The sun's magnetic field wells up to the sun's surface, and they can be gateways for solar storms. So if you look at what a sunspot actually looks like, basically a magnetic field coming up through, they usually come in pairs, coming up through the sun's surface, back down into another part of the sun. The dark spots are because the magnetic field keep that hot surface from underneath come up there, and that's why it looks dark there. Solar flares are caused by a sudden tangling, crossing, reorganization of the sun's magnetic field lines near the sunspot. And you end up with these big, huge arcs that are just tremendous coming out from that. Coronal mass ejections are the particles I was telling you about. And the sun can actually emit, over a very short amount of time, billions and billions of tons of stuff. It doesn't have to be aiming at Earth. It can be aiming in any direction. But sometimes it does aim at Earth. So besides sunspots, there's also coronal holes. Coronal holes are where the magnetic field lines exit and go right into interstellar space and do not come back in to the sun, do not connect back up with the sun. The solar cycle here, as you can see, the 11-year solar cycle goes up and down, it varies in intensity. Each one has a different intensity to it, basically, over time. Our last solar cycle was really pretty much of a minimum. There wasn't much to it. We didn't have much in the way of sunspots. We didn't have much in the way of solar flares. We didn't have much in the way of coronal mass ejections, coronal holes, or any of that stuff. It was really kind of calm. It was basically as calm as it could be, calmer than it's been in the last 100 years. But this current cycle has been predicted to be pretty calm also, but it is showing a lot of signs that it's not going to be. Our solar cycle should peak this year in about 2025, the year 2025, somewhere around the middle of that. However, as you can see in that bottom graph, the prediction basically is that red line. You can see right now it is also way above that already, and heading up pretty sharply. So they think that the predictions now are that it could be quite a impact on the Earth. And when I say quite an impact, should we be worried about impact? Because it really has changed. It does a lot. Space weather actually has a large impact on the Earth, and a lot of things you don't really realize when because you just never read about that in a weather report. You don't read about that in the political news or anything else, or in sports, but it does. In the upper left, you see satellites. Basically, when you have a lot of coronal mass ejection, when you have that, there's a lot of particles in the atmosphere. They slow down satellites. So the satellites slowing down drop to a lower orbit. So it takes fuel to pump them up to a higher orbit. But more than that, there's a lot of space junk. Tens of thousands of pieces of space junk, from debris from satellites that have disintegrated and other things up there. And they're all tracked because you want to make sure that you don't have your satellite getting hit with a 3-inch piece of metal that fell off another satellite. So the space weather tracks these satellites. When you have these coronal mass ejections, it slows them down. It changes the orbits. So when you have a solar storm, they can actually have to look for 4,000, 5,000, 6,000 items that they've lost. They don't know where they are, and they have to reacquire them and figure out their trajectory and their orbits, their new orbits, so they can look for them. Computers and memory gets affected by that, by cosmic rays. The astronaut safety, I mentioned a little bit about that before. The astronauts actually have to go into a hardened place in the ISS when there's a solar storm so they don't get affected by the radiation. When you're in an airplane, you actually get affected by that radiation. If you take a look at when you fly a polar route, you'll typically get quite a dose of radiation compared to going east to west. It's not enough to kill you or make you sick, but pilots have a limited amount of time that they can go over that route, just like dental x-rays. You can't accumulate too many over time, or medical x-rays. Rainfall and water vapor. Basically rain happens when basically the moisture in the air nucleates. It goes around a little nucleation zone and forms drops. The particles coming in can cause that nucleation. You can have the water drops from that and cause more rain. Transatlantic cables are really affected by it. When you have a generator, basically all you have is a magnet moving over a wire. That's all generators work that way. A little more sophisticated, but that's what it is. You take a magnet and you move it over a wire, you induce a current. When these storms happen, they induce ground currents. Those ground currents now, and same with the electrical grids, the ground currents now induce currents in those wires, in the transatlantic ones, in our electrical grid. They can actually cause tremendous problems, blow out transformers, overload the grids. There's been quite a few blackouts because of that. That's something that you want to monitor ahead of time so you have an idea if this is coming, because I mentioned you can see what's going on at the speed of light, but it hits here a few days later, and prepare for that. Satellites will typically they'll put them in a low power mode, turn off sensitive instruments so they don't blow out. They'll be ready to reroute electrical grids and things like that also. Let's see what else. One of the odder ones in the lower left corner there, you see earth currents. Very odd. When you look at pipelines are made out of metal, obviously. Welds are usually a different metal. It's a different metal that is used to weld the pipe than the actual pipe is made out of. Where you have two dissimilar metals together and a current passes through them, you end up with corrosion. So they don't fail instantly, but anytime you get these high currents over these long distances of the pipelines, they start weakening the welds, start disintegrating the welds slowly. The welds get worse and worse and worse, and that causes maintenance. So now what they do is we take a look at that, say, look, there's a storm coming. What they'll do is they'll pump a reverse current through the pipeline to basically compensate for what the magnetic storm is going to do. And you wonder about other things like so many things to rely on electricity and that we don't usually think of. Even farm tractors. Farm tractors rely on GPS, for example. A lot of them do the fields now. They rely on GPS to track along their fields to do the fertilizing, the plowing, and everything else, and a farmer doesn't have to do that much anymore. GPS signals are also perturbed by this. So what's happening now? I mean, pretty much now. Like I said, this is Monday, but it's pretty close to now. There are currently 7 sunspots available. There's a sunspot AR3110 that put off an X-class flare this Sunday. The X-class flares are the highest intensity flares. X1 is the lowest intensity of the highest intensity flares. So it put one off last Sunday, and it actually disrupted communications that they were using radios down to take care of the Florida disaster with Ian. Why were they using radios? Because a lot of their cell towers were down, so they had to rely on radios. And for a couple hours, they couldn't use them because of that solar flare. GPS was also degraded, so the accuracy of where the GPS was telling you were was not there. And in some places it was actually unavailable. There's a new sunspot, a new group of sunspots actually, the AR3112, and that is 81,000 miles in diameter. That's coming in on the upper left-hand side of the screen there. And basically they're expecting quite a bit of problems with that one. First I'll just show you a little bit on 3110 if I can find it here. I lost my cursor. Oh, wrong one. That 3110, that red spot in the green and the blue there is where the radio is disrupted. You can see it's a tremendous disruption, tremendous area disruption. It just hit Florida, but basically the whole western side of the country was disrupted. The radio is disrupted. The AR3112, that large one, 81,000 miles in diameter, is just rotating into view. It's a little bit more than what you can see in this picture here. It's the one on the upper left there. It has the potential of causing a lot of havoc. It takes about 2 weeks for the sun to rotate, so the side facing us to rotate in and then away from us again. But that one has a probability of causing some really explosive mixtures, because there's positive and negative areas that you can see on that map there, lower left, that are very close together. And when you have them close together, that's when a lot of times you end up with big solar flares, where you end up with large solar or coronal mass ejections. What happened in the past? In 1989, it was called the Day of Darkness. I don't know if any of you were around and remember that, but in 1989 it was a huge, huge blackout in Quebec, in Canada. And it was actually hit quite a bit of the northeast United States as well. That was all due to the sun. Nothing happened down here that caused it. It happened to the sun, because of the sun. It caused a 12-hour blackout, basically took down a lot of the electrical grid. Hopefully now we have more warning so that we can compensate for a lot of these things that they weren't able to see coming as fast as it did. But most of New England lost power, but didn't lose that much because we had enough excess capacity that we were able to reroute it. But up in Canada, they did have a lot. Quebec itself sits on a big, large rock shield, and it prevented the current from really flowing through the earth. Current doesn't flow as well through rock as it does through moist dirt, for example. And as a result, basically it got up into 735,000 volt lines and basically took out their transformers, their power transformers. Why is that so bad? They can be replaced. Well, a lot of the larger power transformers there are not spares for. They basically have to be rebuilt. So if we had a really big one, it could cause havoc because we don't have spare parts for it. Even when we do have spare parts, it causes havoc because it takes a long time to replace those things. Aurora were actually visible in Texas and Florida from this one, so you can see the aurora all the way down south United States. Pretty amazing. Biggest one ever recorded on Earth was the Carrington event. That was actually way early. That was in 1859, but it was kind of amazing what happened then. During the Carrington event, really the only electrical stuff we really had up around the world were telegraphs. There were a lot of telegraph lines for railroads going everywhere. That event was so strong that basically they started getting sparks where the wires were on the pole. They started sparking to the pole. A couple of the telegraph operators, were actually knocked unconscious. Some of them got shocks from there, and they panicked in a little bit and disconnected the batteries that ran them. What they first found out is it was kind of odd that they had no power. They had disconnected the batteries. They still could use the telegraphs. They were actually being powered by the sun. Again, that magnetic field over the wire causing that current. They were actually being powered by the sun. It was pretty amazing what it did. The Carrington event, we have not experienced on the Earth anything quite as much as, or anywhere near as much as that was. It was actually discovered, Carrington was an amateur astronomer. And everybody was trying to figure out what happened. They had all sorts of theories as to what it was. But Carrington had actually mapped out these sunspots and noticed just a few days before there was this huge eruption on the sun. And when he saw that and then saw what happened on Earth, he said, I think these two are tied together. Well, he turned out to be right. So, amateur astronomers can make quite an impact. Aurora actually were observed in Hawaii and Tahiti from that event. It was phenomenal. We had a near miss in 2012. Absolutely a tremendous, they said it might have been actually bigger than the Carrington event. Thankfully, it wasn't aiming at Earth. It was aiming away from Earth at the time. You can see in that left picture there, basically it shows the eruption coming in. That was recorded by the stereo spacecraft. There's two stereo spacecraft, stereo A and stereo B. That traveled outward at over 6.7 million miles an hour. And it's really hard to imagine the repercussions if something like that hit the Earth today. As the quote I had here, if it happened 9 days earlier, it would have been facing Earth just 9 days earlier. It just happened to be not facing us. And would have disabled nearly everything that plugs into a wall socket. everything. And not just things that plug into a wall socket, but you think about water, your water pumps, electricity, like I mentioned, farms, stock in the shelves and stores, everything would have been down. It would really be a catastrophe. It would be trillions of dollars worth of damage. But the impact would be phenomenal to happen on Earth. What's interesting, though, is that even a moderate storm, nothing near this can cause a lot of problems. Back in February of this year, there was a storm that wasn't that intense. It was a moderate storm. But 40 of the Musk Spacelink satellites were actually pushed back down out of orbit. They slowed down, as I mentioned, what happened with the coronal mass ejection, and actually burned up in the atmosphere. So if we lost 40 of those satellites due to that one storm in February. That's going to happen a lot, especially with these small satellites that don't carry fuel to push them back up into orbit again once they slow down. They just basically come into the Earth's atmosphere, burn up, and that's the end of them. That launch had 48 satellites on it, and 40 of them burned up in the atmosphere after this space weather event. So that wasn't a big one, but that was big enough. A storm strong enough to disrupt our life, basically. Doesn't have to be as big as the Carrington event, but something that would really disrupt our life. Is estimated that we have about a 12% chance of it happening within the next decade, any decade, basically, within the next 10 years. It's hard to think what life would be like if everything that was electronic went away, and a lot of it was blown right out. So even when you got your power back, it would not work. But now a little bit about the fun part, the aurora. I love aurora. I've only seen 2 in my life. I wish I could see more. When I go down to Antarctica, I go down there in their summer, so I don't see aurora because it's daylight 24 hours a day. But the aurora comes in where those charged particles come in at the cusp, those 2 areas, north and south magnetic field where they come in, and they interact with the atoms in the Earth's atmosphere. Basically what they do is they push them up to the electrons up to a higher orbit, and when they fall back down again, you get light. Fluorescent lights work exactly that same way. It's exactly how our fluorescent lights work. And when you have different atoms in the atmosphere at different altitudes, you get different color aurora. Red, for example, is from oxygen greater than 150 miles up. Blue from nitrogen less than 60 miles. It changes all the time. Basically, as different energies come in from these come in and hit the atmosphere at different levels, you'll see different colors. But they work exactly like a fluorescent light. A little graph on the lower right, you can basically see aurora that was taken from the spacecraft over Antarctica. And this one was taken, this is a time lapse at the geographic South Pole, what the aurora looks like. And you see those little streaks going across. Those aren't planes. You don't have planes going down there. Those are actually iridium satellites. The iridium satellites are what we use for communication. And they're the satellites that go in a north-south orbit, not around the equator like most satellites do. Well, what about here? What about at the observatory? Can you see aurora here? Well, yeah, you can if the space weather is intense enough. Basically, we've just had a few storms. We had storms going up to a KP index of 5 this past week. But if you can look at this graph, you can see right around here, a KP of 7 is what you'd really need to get aurora. How can you find out? Well, there's a lot of different places on the web to look. But spaceweather.com is a really simple one, and it's got a lot of links in it too. So you can, if you get interested, you can look at a lot of different things that have to do with space weather, the sun, what's going on out there. But I recommend it. And on the lower left, you'll see one of the little graphs they have there, and it basically shows where the aurora was visible when I did this again on Monday, and what the KP index is. The KP index then was 3, it was quiet. But in 24 hours before that, they had a storm, a KP index of 5. If you check, you can actually even sign up for alerts. But if the KP index is 7 or greater here, you've got a really good chance for aurora. Obviously not on a night to night, which is wonderful for radio observing, but not for optical observing with all the clouds out there. As you can see also, the further south you go, the stronger that storm has to be to see it. And being the fact that some of those storms are visible down by Florida, down by Hawaii, you can just imagine how strong those storms were to see there. Well, why do we go to Antarctica? Drew mentioned that you can do things there you can't do anyplace else. And it's true. You also get a little cold, but it's a great place to be. I absolutely love it. I'm very thankful for my once-in-a-lifetime opportunity to go down there, as my wife put it. That's happened 8 times in a row. So, you know, the first time it was like, I was like, "You want to go?" I was like, "Yeah, right now." No, not now. You know, wait till November. And I got all set and told my wife, she said, "But what an opportunity! You can't miss it." I think about after the 8th time, she was like, "Well, maybe not so much anymore." But why go here? Well, there's a few things that are very unique to Antarctica that we don't have here. One is that cusp, that region where all those charged particles come in. You have that at the North Pole and the South Pole. Well, the problem with the North Pole is there's no land. Basically, you're just sitting on ice. But that's the gap in the magnetic field where all the plasma in the sun comes in and hits the Earth's atmosphere, where we can monitor it. It can be studied continuously, but if you study it from a satellite, the satellite just passes overhead and it's gone. Typically, the satellites will orbit in 90 minutes. So you maybe have 10 minutes where you can really see what's going on, and it's gone again. But when you're down at the South Pole, it's right there. It's overhead 24 hours a day, day and night, summer and winter. In the winter, you have 24 hours of continuous dark. So if you're doing astronomy, for example, you can look at the same area of the sky, because remember, we see the stars moving at night. They pass over us. Well, it's actually the Earth turning around, but it looks like the stars are just moving past us. There, the same stars are overhead. They just spin, basically just spinning in a circle. So you can look at the same area of the sky all the time. You don't lose view of it. 24 hours of continuous daylight in the summer. Well, that's even more important when you're looking at the sun, because now I look at the sun with no interruption. It's not going behind the Earth. It's always there. It's right overhead. So you get basically almost 6 months where you can study the sun continuously. You can see things that are precursors to things happening, but you can also see how it fades out after an event and not miss any data on that. And there's really no electromagnetic light. There's no industry down there. There's no light pollution. There's low atmospheric moisture. If you're looking for things in like the microwave area, atmospheric moisture absorbs much of that signal. Much as if you put a glass of water in your microwave oven, it gets hot because it's absorbing the microwaves. The same type of thing. And I mentioned a large area of landmass. So you can set things up all over the place, and they don't melt and fall into the ocean, which is kind of nice. Most people don't think much about Antarctica because it kind of looks like a coffee stain on the bottom of a map. There's really not much to it on usual maps. And if you have it on your globe, you don't even see it at all, because usually it's at the bottom of the globe, and you just, unless you get on the floor and look up, you never see it at all. But it's actually huge. It's about 1.5 times the size of the United States. In the winter, it's much bigger once there's ice around Antarctica. Here's a lot of text, but I'll tell you a little bit about it. First off, that map that you see some light gray areas and dark gray areas. Dark gray areas are the landmass. The light gray areas, the white that's touching it, are permanent sea ice. That's sea ice that never melts. It's on the ocean, but it never melts, winter or summer. It's a cold place. The coldest recorded low officially was a minus 128 degrees. But on Dome C, they recorded temperatures at a minus 140, but it was not official. At the South Pole, if you took the average year-round, it's 57 below zero. 99.7% of the continent is covered with ice. Just think about that. The whole thing. Just imagine the United States almost all covered with ice. And it's over 1 mile thick. Some places are actually much deeper than that, almost 3 miles thick. It's very dry. Like I mentioned, hardly any moisture. It's very windy. High sustained winds, 218 miles an hour. Not a tornado, it's just wind. At Vostok, the Russian station, the average 50-mile-an-hour winds year-round. It's very high. The average elevation of the whole continent is 6,500 feet, and much of it is above 9,800 feet. There's mountains, the Transantarctic Mountains. I'll show pictures of them. It's also kind of lonely. There's not many people there. For something 1.5 times the size of the United States, in the summer there'll be somewhere between 1,000 and 5,000, depending on the year, scattered around the continent. At Pole Station, there'll be 120 in the summer, 40 in the winter. At McMurdo, which is on the coast, there'll be 950 in the summer. Again, a very low number in the winter. And at the remote sites where I work, you'll have as few as 3. Actually, the highest number we ever had were 5 people. And they're way out in the middle of nowhere. How do you get there? Well, first, it's a nightmare. First, you have to fly to Christchurch. But to do that, I leave from Newark. And then I fly to Dallas or somewhere else on the West Coast. And then from there to Auckland, New Zealand, which is the North Island of New Zealand. And then take a small plane to hop over to Christchurch, which is on the south side of New Zealand. Our shortest trip to get to Christchurch was 24 hours. Our longest trip was 45 hours. We actually used to, believe it or not, fly to Sydney, Australia, way out of the way, and back again when we had American Airlines. Now we go with United, and they go directly to Auckland, which cuts about 2,000 miles of flying out, which is kind of nice. It's a long trip. That flight from Dallas to Sydney was 16 hours in the air. A real long trip. Once you get there, though, you'll stay at Christchurch for some indeterminate number of days. You really never know how many. It always depends on weather and crews and mechanical condition of the planes, because we take commercial planes to get to Christchurch. But from there on, we're with the Air Force, or one of the Air Forces, sometimes the New Zealand Air Force. So then you add another 2,300 miles to get to McMurdo, and then another 840 miles to get to Pole, and then where I work is maybe another 2 or 3 or 4 or 500 miles from there. So it's a long trip. The little dots on the map are the places I go to. The yellow ones are manned stations. The one on the bottom there is McMurdo. That's on the coast. It's where all the distribution of all the material comes from. The one on the upper, kind of towards the middle, is actually the South Pole. That's the geographic South Pole. If you look down the lower right, you'll see where the magnetic South Pole happens to be a couple of years ago. Actually, I haven't updated this, but it's very close to there. It wanders. Over the last couple hundred years, it has wandered from very near McMurdo all the way over there. And now it's not even on the continent of Antarctica. It's actually out in the ocean. To the right, you can see Concordia stations. Concordia station is a French-Italian station. And I will go there, or we will go there, sometimes to get to one of the EGOs, the blue dots. Those are the remote stations that I work at. I call them stations, but they're really next to nothing. They're 8 by 8 by 16 foot fiberglass boxes that are out on the ice. And we fly out there and work. We used to fly directly from McMurdo to EGO 5, the one on the lower right. We don't anymore. We go to Concordia because it's easier to get to. The one with the red X in it is a little bit different. That was EGO 6. We had Automatic Geophysical Observatory 1, 2, 3, 4, 5, and 6. Well, 6 wasn't visited in quite a few years, and it's now estimated by the meteorologists to be between 60 and 70 feet below the surface of the snow. It's been drifted over, and it is just gone. We will never go there again. So it's gone. That's it. It's just gone. So the first thing you do when you get to Christchurch is you get outfitted in clothing for Antarctica. You don't have to buy that clothing. You bring a lot of it your own, but they have special emergency cold weather clothing that you bring. And that includes the jacket, which is called the Big Red. And you have Carhartt pants. You have boots with really thick soles on them so your feet don't get cold, because you're always standing on very cold stuff. When I get down there at beginning of November, it'll be about 40 below zero. It's the beginning of summer. So you want the nice thick boots. You also get the gloves, the balaclava, all different things that you have to have with you. And you have to actually wear all that on the plane. You can take the balaclava off, you can take the gloves off, but they'll check it to make sure that you have that before you can get on the plane. There's a reason for that I'll get into later. Some of the flights we fly down on a C-130s usually, or a C-17. I'll show you a picture of my last flight. This is a C-130. Don't ever complain to me about 17 inches of seat width. We actually got so tight in there, we had to interleave our legs together to fit. And mind you, this is a flight that's 8.5 hours. So really kind of interesting. The other thing that's kind of interesting, kind of an aside, when you go through TSA here when you fly, it's like, do you have any nail files, any sharp objects? Oh my gosh, get that out of here. They do the same thing there. But once you get on a plane, I saw something that was pretty odd. There's hatchets mounted on the wall. They just clip on. And, on a plane you have the emergency door. Are you qualified to sit by an emergency door? Because you can open it, and the slide comes out, and inflates, and down you go. Well, on the C-130, basically you chop through that area there. Just chop your way out of the plane, and out you go. Now, I mentioned a flight is about 8.5 hours on a C-130 to get to McMurdo from Christchurch. But that's only when things go well. things don't always go well. You can have bad weather along the way. And if you have bad weather along the way, they'll turn around and go back, called a boomerang flight. So you actually have a boomerang bag with clothes in it so that when you get back to Christchurch after your boomerang flight, they palletize all your luggage. So all you have is this one little cloth bag with whatever you want to put in it. And that's what you get to stay with until you can actually fly down again. First year down there, or I guess second year down there, I didn't put anything in that bag, figuring the first year went so well. It boomeranged, and I ended up with basically all my old clothes, the same clothes day after day after day, same underwear, same everything else. Never did that again. So the last time I went down was 2019, 2020. We basically got shut down because of COVID since then, but starting to go, open up again. And on that flight, we actually went out five times we tried. 3 times we actually got on the plane, get up at 3 in the morning, go to the airport, get on the plane, get buckled in, sit there, wait. Nope, we're not flying today. Back you go to the hotel, take a shuttle to the hotel. 2 times we took off. The second time we took off, we actually got 5.5 hours out. So we went out over 3,300 miles on a plane. And then they said, nope, weather's bad. We've got to turn around and go back. So 11 hours on the plane and ended up at the same airport that we started at. Kind of mind-numbing in a lot of ways. But what's also interesting is that the area where we turned around there, where the end of that line is called the point of safe return. They used to call it the point of no return, but they thought, oh, that sounds terrible. We'll call it the point of safe return. If you go past that line, if we went another 10 minutes, we would have been committed to having to go to McMurdo no matter what the weather is, because they wouldn't have enough fuel to go back. So that was the last call they went, and apparently it was right on the borderline of something you could do, so they figured to wait till the last minute. They did. It turned out to be bad weather, and away we went. So that was, on the way back too, the engine was shaking like crazy. On these planes, the C-130s are kind of old planes, a lot of them, and there'll be a lot of the flight crews back there all the time with flashlights, checking the hydraulics, making sure there's no leaks. It's kind of a little bit unnerving, but you get used to it over time. But we finally did get there. And on the way in, you fly over the Transantarctic Mountains. Transantarctic Mountains are beautiful. They divide east and west Antarctica. And it's one of the biggest mountain ranges on Earth. It's 2,300 miles long. It is gorgeous. Now, you don't have beautiful windows on the C-130, but you do have portals that you can look out of. And I always manage to get to walk over to one of them and get my camera out and take a lot of pictures, because I just think it's gorgeous. They almost look like some kind of a watercolor, a surrealistic painting. It just gorgeous. You can fly over these for quite a long time. You can also see where the glaciers start. You can see the glaciers running through in the valleys where all the ice is basically getting thicker and thicker as things are piling up with snow, and eventually it gets heavy enough and just starts squeezing out, moving out again. But eventually we got there. We landed at Willie Field. There's a couple different airports, loosely airports, for the United States and Antarctica, but all of them aren't on land. There's none of them that are on land. You actually always land on the ocean, frozen ocean, which is kind of a strange thing to think of. But they actually have 24 feet of compacted snow sitting on another 8 to 10 feet of ice. And under there is another little over 1,000 foot of water. And all their airports are on the ocean, basically ocean snow. You can see basically here Pegasus Airfield. You can see quite a few of the different airfields there. Pegasus Airfield is the one on the lower left. That's where we always used to go. That's now closed. The reason it's closed is because Black Island, which is way down on the lower left, is a volcanic rock, as well as the island where McMurdo is. But that one is called Black Island because the winds there are so strong it scours all the snow off of it and actually starts scouring that rock, and you can see that black moving out. So basically what it did is started flowing towards Pegasus Airfield, and the black absorbs the sun, it melts the snow, makes it a little bit squishy, the planes can't land there. They ended up building a new airfield to do that. They used to have an ice airfield that you can see closer to McMurdo itself. They stopped doing that. That was actually the airfield I first flew into, I think the first 2 years. And that one actually melts down to just pure seawater. And they drag all the equipment out there for the airport. You land, take off, whatever you're doing, and middle of summer comes, they drag everything back, and that airport is now just ocean. It's water. In the lower right there, you see an airplane. That airplane is a Lockheed Constellation, a C-121 Lockheed Constellation, and you can see it's kind of buried in the snow. Above that picture, you can see it's out there in the snow. You can actually see it from Pegasus, from the airport. What happened with that plane is that is the reason everybody has to wear all that emergency cold weather clothing on the plane. They were coming in, they got past the point of no return, so they were committed. We had a condition 2, bad weather, not the worst weather, but bad weather. Apparently the pilot made a perfect landing. Unfortunately, there was a 6-foot snowdrift, caught a wing, ripped the wing off, and that was the end. That's where the plane sat. Being condition 2, it was kind of bad weather, so they had to go 14 miles out from McMurdo to get to the plane with the vehicles that transport the people. And it took them a couple hours. A couple of people did not have the emergency cold weather clothing, and they had a light case of hypothermia. So from that point on, it was you're taking this on a plane, you're having it available. You're not going to have it packed in your luggage, you're going to be wearing it. Which is also not so bad because basically the planes are not heated that well either. But the new flights can now handle about 60 C-17 flights a year, which is pretty amazing. When you get down there also, the other thing you'll notice is that vehicles are pretty strange. This is called Ivan, the Terrabus. And it's, I don't know how many horsepower it is, but it's really anemic. It does not have much power, but it can gear down to about anywhere with the thing, but you get there slowly. It's 67,000 pounds. It's a very heavy instrument bus. You can also see a 6-wheel drive, so it can go through quite a bit of stuff, but we've been stuck on that too, actually, and then they come out with a Cat D9 and pull us out. Getting to McMurdo itself, McMurdo is not pretty, not by any stretch of the imagination. It's actually, it looks like one of the worst industrial towns you've ever seen. McMurdo basically started out as a Navy station, and as a result, a lot of those buildings are there since 1959, and they haven't been repaired that much. So it is the center for everything that goes on for the United States in Antarctica. That's where all the equipment comes in. That's where everything goes out. It's the distribution center. It's all the logistics are done there. All the fuel is stored there. And you see Observatory Hill in the back there. You may be able to see there's big fuel tanks in front of that. There's 17 million gallons of fuel they store there. It's called AP8. Jets usually use JP8 jet fuel. Down there they use AP8. It's an Antarctic blend of jet fuel, but it's very close to the same thing. You have to have everything that you have up here down there. You'd like to think there's just a bunch of scientists going down there, but you need people to cook. You need janitors. You need welders. You need carpenters. You need electricians. You need everything you need here. You know, a storeroom. You need people that can fix things, people that can build things, people that can develop things. So you really have a community. It's almost a town. It really is almost a town. Nobody lives there, but people go down there every year. Like I mentioned, typically now about 950 in the summer. I think about 100 and some odd in the winter. Uphill in the background, usually the first day you're down there for the first time, and usually every time, you walk up that to get a view of things. This is a view from the top of Ob Hill. That cross was erected in 1913 in memory of Captain Scott's failed South Pole expedition. They put that cross up there and kind of waited for him to never return, or to return. He never did. In the background, you can see Willie Field, the airport. That's it. It's out on the ocean. That cross is up there. It's just beautiful to walk up there and look around. You're looking out over the ocean, and you're actually seeing the continent of Antarctica across the way. We're basically on Ross Island. McMurdo's on Ross Island. Here's a little bit of a different view of it. You can basically start seeing some of the fuel tanks. They're really huge tanks. You can start seeing in the background the dorms, the galley is there, and all that you can kind of get a feel for all these types of shops and everything else that you need to do. In back of the dorms, before that last hill, is where the ships come in. That's the dock there. So when you first get down there, you do orientation and training. You do the same orientation and training every single year. Don't take a chance. Even the physical qualification, when I go down there, they actually check my blood type every year like it's going to change. But they do the same thing every year. But it's pretty amazing. One of the things you start noticing, the first time I was down there I was kind of amazed, is the weather is a little bit different than it is up here. South Pole weather, condition 3 is acceptable weather. That's nice weather. Condition 2, where I mentioned that plane came in at, is a little bit dicey. Higher winds, wind chill can be 75 to 100 degrees below zero, and low visibility. A lot of times snow accompanies that. Condition 1 is the worst weather. That is phenomenally bad at times. Wind greater than 55 knots, obviously. Temperature, wind chill lower than 100 degrees below zero, and visibility less than 100 feet. I'm going to flip real quick. I don't know if this is going to work. I didn't try it before. I hope I'm not doing something stupid. And try to hit this just to show you a little bit of what condition 1 looks like.
You need to drag it onto the other screen.
I do? Okay. Well, we won't do that. Oh.
Okay, hold on. Can you stop that? Okay, so let's do this. Let's see if we can.
I did something stupid.
No. Let's see if I can.
How many wanted me to minimize it or?
That's not what I wanted to do. Was to. So that I can actually try to move it. I guess I need to sort of reduce it so that it's not a full screen.
How about we just don't do that?
Okay. I see it come up later.
Yeah, I shouldn't have done that. So, anyhow, the weather gets really, really bad. And if you later, I will show you a short video about a minute or two long that shows you what condition 1 is like. It is phenomenal. It can be really bad. At Black Island, where I told you it scours all the snow off, I have a video of that too. Wind speed was 223 miles an hour, and the little hut that they have there was just completely packed with snow that didn't come in through the door. It came in through the seals around the windows. Just absolutely amazing. And their satellite dishes there have a dome around them made out of Kevlar. So the first year you go down, you do Happy Camper. I mentioned I work at Deep Field, so I'm working out in the middle of nowhere. So Happy Camper is where basically they check to see if you can kind of work out in the middle of nowhere, kind of by yourself or with just a couple other people if you can take care of yourself. Not so much first aid, because we have a mountaineer that goes with us that knows the first aid. But just can you set up tents, can you take care of things like that? So we go out and they take us out to, you go through classes to learn things, how to use the little stoves, the little gasoline stoves that you have, how to set up the tents, how to repair things. And then they take a bunch of us and they drag you out on the ice way far away from anything else and let you sit there with people you don't know, because a lot of different people are taking this. So they basically took us out there with snowmobiles and dumped us off with our tents and things like that, and then took off again. They said, we'll see you tomorrow at some point. At that point, we set up our camp. In the background was Mount Erebus. Mount Erebus is the world's southernmost volcano. It's an active volcano. It's actually one of 3 in the world that has a lava pool on the bottom of it. It's an active volcano. It was kind of a nice backdrop. But we set up our camp. So the first thing we did was start digging the ice. It's really kind of really hard snow. And you dig out blocks of ice. And you cut them with a saw sometimes because they're really hard. And then you set up your tents and you make a wall. The winds there are typically katabatic winds. Katabatic winds go from high altitude to low altitude. So basically cold air is coming down. Just like when you open your refrigerator, it kind of falls on your feet. The same thing happens. It goes from high altitude to low altitude. So you typically set up a wall so that if the wind does get strong, if a storm does come up, it won't blow your tents to pieces. And we got a little bit carried away because it was a beautiful day and we just made one heck of a big wall. We also made a kitchen out of it. And everybody set up their tents. I decided, being the age I am, I have not had a snow cave in a long time. So I made a snow cave instead of setting up a tent. I did help set up the tents, but then I dug into the snow and I made a very comfortable place under there that you could sit up in. You couldn't stand up in it, but I slept there for the night. One thing I noticed, found out that wasn't so nice though, is that snow is so hard packed. When anybody walks underneath, you just hear crunch, crunch, crunch. Even if you're like 40 feet away from you, it's amazing. Then you go through more training. One of the things we do is, since we're working at really high altitude, they put us in this gamma bag, and you learn how to basically pump that up with air. And if somebody is having altitude sickness, this is how you mitigate it until you can get help. Sometimes it can be a real long time to get help. They stuck me in it, and that was one of the people I work with who actually wintered over in the back there, and he was just loving it. He pumped it up so much my ears popped. Is there help down there when you get sick? Yeah, there's a hospital. Here's your hospital.
Ambulance parking lot.
Yeah, and the ambulance is basically a truck. So there's no ambulance. But that's the hospital. It's actually pretty well stocked inside. There's the dispensary. They have quite a few things there. Another just little thing, another thing. You look at the clocks, they're a little bit odd. Notice the clock's got north, north, north all the way around it. The odd thing about, though, there's actually a dentist chair in that hospital. And a few years ago, I knew the nurse. She was telling me a story. She said one of the guys came in here, and he was deathly afraid of dentists. And he's sitting in a chair, and he's just shaking. He had a bad abscess, and they had to pull a tooth. I just got to tell you, the guy came in, he goes, I'm really afraid of dentists. And being a dark, dry humor that's always down there, he looked and said, we should have no problems then because I'm not a dentist, and pull his tooth. Animals. You don't see animals anywhere except by McMurdo. Once you get into the interior, there's basically nothing. But there are skua. Skua are kind of weird birds. They're a lot like seagulls. If you ever go out to the shore and have food around, seagulls will get it. Skua do that tenfold. They typically hunt in pairs, and they typically go after eggs, things in the ocean, small birds, other birds that they can get. But they are very, very, very aggressive. They're also quite a bit bigger than seagulls. And if you come out of one of the buildings at McMurdo with food in your hand, you can almost be assured one of them is going to come and hit you. I mean, they don't just come near you. They come and just smack you with a wing. You drop your food. They're all happy. They come down. They take your food. So then what they started to do is they take a plate, put another plate on top of it, wrap it in saran wrap. They do that. You knock it down. You pick up your plate. It doesn't fall apart. And you keep walking and laugh at the birds. One of the best things I saw was a guy that came out there with a bag of chips. He had one chip in his hand. He was eating them out of the bag, a little bag like that. And all of a sudden, boom, chip's gone. He's like, boom, bag's gone. He just stood there. He's like, oh, that's it. So yeah, you're not supposed to get too near. You're not supposed to get near any of the animals that are down there. If you disturb them, you're considered to be too near. But there's also quite a bit of penguins down there. Two different kind of penguins we typically see are Adelie penguins and emperor penguins. The Adelie penguins are not that big, this tall. The emperor penguins are a lot bigger than I ever thought penguins were. They can be up to 4 foot tall. It's a penguin, and no wonder they don't fly. They weigh up to between 50 and 100 pounds. They are big, big birds. None of the animals or birds are afraid of people whatsoever down there. They just couldn't care less. But those emperor penguins are just gigantic. They're absolutely gigantic. There's also seals. The seals that I see typically are Weddell seals. And they're kind of odd. They come when the ice starts to break up, when summer's starting to come around. The ice will get cracks in it and break up. And these Weddell seals will come up through a hole in the ice, and they'll just thump along for like 100 feet. I never figured out why. And then just lay there for the whole day, and then thump back and go back down. It's ice. Just come up, sit here. You don't have to go way over there. It's the same ice. But they do that. It's just really odd to see. But they're really big. They're like a Volkswagen made out of fat. 1,200 pounds, 10 foot long. They're really, really big. They can dive down a quarter mile to 2,000 feet. Beautiful to see underwater. And see underwater, how do you do that? Well, at McMurdo, sometimes they put in a dive tube or an ice tube. Basically, this tube is cut through the ice. There's about 8 foot of ice, and you can go down into the tube. You crawl down a ladder into it, and you're actually now in a tube, and you're under the ice, where you can actually take a look at things around you. That seal is a little bit of a timed exposure. He does not have oval eyes like that, but that looks like in a picture. There's a lot of ice you see around that dive tube, and the reason for that is the seawater freezes at 28 degrees. So the air coming down into that dive tube, which is made out of metal and plexiglass, is a lot colder than 28 degrees, so it starts freezing around there. So it freezes to a point, and then they pull the dive tube up again to melt it. But there's divers down there too. There's divers under that ice, and they're looking at all the different animals down there. And there are some weird animals. They bring these up to the lab at Prairie Lab, and a lot of really strange creatures that I've seen there. The one is this little sea spider that I was holding in my hand. And I was just trying to figure out how that thing worked. It looked like it was all legs and nothing else. But apparently it's alive and it moves and it does its thing. When I'm down there at McMurdo, I work at a place called the Rival Heights. Rival Heights is the pretty much a hill, not uphill, but a different hill up and back of McMurdo, the town type thing. I mentioned it could be windy. That's why you have to take your cargo containers and weigh them down with concrete blocks so they don't blow away. It does get that windy down there. It's amazing. This is the area where I work when I'm there. I don't work there for too long, but this is where some of our instrumentation is. This is the inside. This is where the instrumentation is. A lot of the similar instrumentation we have at our AGOs, which I'll show you a little bit later. And I mentioned Black Island. Here's a picture. I didn't know I had it in here. Black Island is where all the communications for McMurdo is done. Basically, we use equatorial satellites, ones that are at the equator, but you only can see them at 5 degrees above the horizon. So Mount Erebus, that big volcanic mountain, is in the way. So what they did is set back on the continent of Antarctica, right next to the continent, on Black Island, where you can just skim over the top of that mountain. You can get satellite coverage. It's very slow satellite, but it's there. But it also shows a little bit of the wind experience there on Black Island. Basically, if you equate them to hurricanes, once a week, Category 1, once a month, Category 3, and every winter, at least every winter, they have a Category 5 on that little island. And those are the Kevlar domes I was telling you about. This is an LC-130. I told you I took a C-130. Basically, that's what you take to get to Christchurch. You take an LC-130 to get to the South Pole. They're actually flown out of Schenectady, New York, the 109th Airlift Wing. And the difference between those two planes is this one, as you can see, has skis on it. So it can land on the snow at the South Pole. Much more comfortable flight than the other one because you have very few people on it compared to that flight from Christchurch to McMurdo. That little dome thing that you see kind of on the wall there towards the left near the orange bag that's hanging, that's the urinal. So, your privacy is you basically pull that curtain around you. Now, it's the same with that first flight where we're all sitting leg to leg interlocked. So when somebody had to use the bathroom, you literally had to crawl over the top of people to get to it. Pretty embarrassing. I also mentioned you can see out of those little portals. This is one of the portals. Again, we're flying over the Transantarctic Mountains. Beautiful. You start seeing the glaciers. You start seeing them flowing down. Here's the starter one where you can see it basically pulling up and starting to flow down through the valley. Absolutely amazing to look at these things. Beardsmore Glacier, this one here, is 25 miles long, 25 miles wide and 125 miles long. Phenomenally big glacier. It drops close to 1.5 miles in height over that distance. Just beautiful flying through there. A long time ago, when they first started exploring getting to the South Pole, this is the route they used to take to get there. It was quite steep, but they didn't have to climb over mountains. They'd go up the glacier. They found in 2016, they actually found beetle fossils there that were about 20 million years old in the glacier from when Antarctica used to be tropical, which is kind of funny. Finally land at the South Pole. It's called NPX, which I found very confusing. That sounds like it would be North Pole, but it's Navy Pole Expedition, and the initials just stuck. When they land there, the plane never stops. Basically, the propellers are going all the time. They basically, as it's running, they take any cargo off of it, we get off of it, and they turn around and go right back out again. They also bring in fuel every time. They don't take on fuel at the South Pole, they bring it to the South Pole. That plane always leaves with 100% of its fuel tanks filled, and when it lands, they pump off anything it doesn't need to go to the South Pole station for fuel. Sometimes they do a military unload of the planes, depending on what's going on, if they're expecting bad weather and are really in a hurry. A military unload, basically what they'll do is, they don't do it when there's people on it, but basically they'll open that door in the back, that big trap door in the back, and they won't even stop on the runway. They just push everything out the back, and they just out they go, away they go again. Pretty amazing to see. I have a video of that, but not here. South Pole Station itself is a lot different than what we saw at McMurdo. It's actually really kind of nice. It was completed in 2010. but you're really isolated there. The building you see here has a gym in it, a cafeteria called galley, a music room, dorm rooms, a science lab. It's got everything you need really in it. Down below the surface are generators to keep things running. You can see a little bit of this is kind of the area around it. What I wanted to point out here is the ceremonial pole, ceremonial South Pole, and back of the South Pole Station. That's the one you see with all the flags and the little ball. That's not really the South Pole, by the way. South Pole, way over on the left there, you see the geographic pole. It's different. It's different, and it keeps getting more different. If you look at our universe down there, this is it. That first picture is the stuff on the left. There's different observatories, Ice Cube Observatory, South Pole Telescope, BICEP, the MAPO Observatory. Once you're away from there, there's nothing. As far as the eye can see, in fact, as far as you can go. 797 miles to the next permanently manned station. And once you're there, from the middle of February on, there's no way to get out. Basically, you're stuck there, except for emergencies. And there's been 3 emergencies since this was built. Oh, by the way, when I got there in 2016, we had a visitor that I wasn't expecting. Buzz Aldrin was there. Buzz Aldrin flew down. He was 86 years old, and he wanted to visit the pole. It was on his bucket list. It costs about, when I last looked, it was $54,000 to take a 6-day trip there. You don't get to stay in the South Pole Station. You get to stay in basically tourist tents that are about a mile away from the South Pole Station. He flew out, paid the money for his trip. They fly out from Chile to get there. I think this is just really kind of odd for the second guy on the moon, got altitude sickness. So he was there for a little bit of time, very sick. You can see him here. He doesn't look really too hot. And they flew him out on a plane that I came in on. Pretty amazing that he made it there, though. And he still says he wouldn't have missed it for the world. That was really where he wanted to go. He definitely wanted to go to the South Pole, and he made it. What's the weather like down there? Very, very different than it is at McMurdo. At McMurdo, you have very high winds and kind of cold temperatures. It'll go 50 below at certain days. South Pole, it gets very cold. In the middle of winter, you can get 100, 160, 170 degrees below zero with wind chill. Also, you have a lot different altitude. Obviously, McMurdo's at the shore, you're at sea level. At South Pole, you can get up pressure altitude well over 10,500 feet. Pressure altitude is different than the actual altitude. The actual altitude at South Pole is 9,301 foot, according to USGS. 9,000 foot of that, by the way, is ice. There's only 300 foot of continent. It's 9,000 foot thick ice. So basically, you tend to be at very high altitude. You don't have as much power, and altitude sickness will hit people. Also, your ideas of what normal weather is can get kind of weird. Here you can see the little newspaper they put out. The weather briefly turned milder after the storm, with temperatures approaching minus 30 degrees Fahrenheit. So a warm day. The ceremonial pole. There's 12 flags there from the original signers of the South Pole Treaty in 1959. But it is a ceremonial pole. It is not the actual pole. The actual pole is located every January 1st. The USGS comes down and marks it, and that's actually the pole that the Earth's spinning at. So the Earth is always spinning on that pole. But the problem is you're on 9,000 foot ice, and that ice shifts. So it slides about 33 feet a year towards the ocean. So every year, that marker is moving. So every year you have to put it back. And next year, put it back. So every January 1st, we have basically a celebration where we grab the marker, the actual marker for the South Pole and the sign. Everybody gets together. We put the new marker in and put the South Pole back where it belongs. And it's good for a good couple of days. If you noticed on the south side of the South Pole Station, there was kind of a metal tube. That's called the beer can. You can also see a little bit what the snowdrifts are like there. But that's called the beer can, and it actually goes down below the surface. So once you get down there, you're basically in tunnels underneath the snow. That's where the fuel for the South Pole Station is stored. There's 475,000 gallons of fuel to bring them through the winter. And that's why the planes bring in the fuel every time they come in to keep this full. This is also where all the food is stored. I mentioned the average temperature, year-round temperature is 57 below. So all the food is at 57 below zero. So it lasts for a real long time. Typically you'll find food there that can be 10 years old or 5 years old at least. Ice cream, get in 5-gallon buckets. You bring it back up into the galley. You can't get into it. It's just so rock solid. You have to wait usually a day or two before you can actually scoop ice cream out of it again. I found out that if you use a spade drill, a wood bit on a drill, you can drill into it. It kind of works out well. There's ice tunnels beside that. There's 1,900 foot of ice tunnels. That's where we get our water from. Mind you, you're at a place that's always frozen at 57 below. There is no water. So the only way to get water is to melt ice. The ice is so pure that they actually have to put minerals in it, otherwise it will leach the minerals out of your body, all the electrolytes out of your body. So they actually put minerals in the water. To do this, they have these things called rod wells. And basically what they do is they sink a hot plate down, melt through the snow, or through the ice, and then they circulate hot water through that constantly to keep it melted. The hot water comes from is heated by the exhaust of the generators that run the station. They can get about 2,500 gallons of water out of that per day. So they get quite a bit. Eventually, though, it gets too big and they can't keep it thawed. And at that point, it becomes a sewage dump and they build a new rod well. If you look at that old picture, you can see all the circles. Those are all the proposed and existing rod wells that are there. So to go into the ice tunnels, it's not a very spectacular thing to go into. Basically carved out with chainsaws and heated pipes that take your water and bring it back to the South Pole station. And you can see here the temperature is 57 below Fahrenheit. About 48 below Celsius. Down below the surface area is kind of a weird thing though. People tend to put little mementos down there. You see that sturgeon in the upper left there? That sturgeon was actually brought to McMurdo one year and nobody knew what to do with it. So they left it there and it started to rot. And they said, we'll bring it to the South Pole. They brought it to the South Pole on one of the flights and I brought it down into the ice tunnels, made a little place for it, and it's been there ever since. You also see a pig skull on the left, something made out of a power tool on the right. There's all these weird little things down in the ice tunnels. So after Buzz Aldrin was there, of course, we had to make a memento. I actually didn't do this. One of the guys I was with did this. So they put a plexiglass thing with the glass that Buzz Aldrin drank out of and a tissue he blew his nose in. That's now on permanent display down in the ice tunnels. I mentioned also that you couldn't get out of the South Pole Station between February and November, basically the end of October. You can't because it's too darn cold. Hydraulics on a plane will not work. So the only way you can get in there is with a plane that doesn't use hydraulics. They use twin-engine otters. In 2016, it was a midwinter medical evacuation. These twin otters come out of Canada. And they had to fly all the way from Calgary down to the South Pole. It took them 8 days to get there. When they got there, basically what they did is they put heaters on those called Herman Nelson heaters on the engines to try to keep them warm. They had basically 55-gallon drums cut off, put jet fuel in them to mark the runway. They sent 2 planes down. One of them stayed at Rothero, one of the other sites, just in case one of them didn't make it all the way. They had at least one to get down there, and they were able to evacuate a person. This is one of the 3 evacuations that they've done down there. The twin-engine otters are like the John Deere tractor of the sky. They can go anywhere. They don't use any hydraulics, so they're good to go. But the most amazing one I ever heard of was not an evacuation. In 1961, his Russian doctor, had appendicitis, and he had no way out. He had to operate on himself. So he started operating on himself with a mirror and gloves, cutting out his own appendix, and said it was too confusing with the mirror because everything was backwards. Got rid of the mirror, got rid of the gloves, and did it by feel. He lived. I think that's just absolutely amazing. Absolutely amazing. I just can't believe it. I mentioned that they take the fuel to everything used to come into the South Pole Station on those LC-130s. But over the last decade, they started with a traverse. A traverse is a way to get stuff there over land, actually over ocean, over land. So they start off on the lower side there is McMurdo, and then they go over the sea ice, they go up the glaciers, and then they go over the plateau to the pole. It's 1,040 miles. It takes them about a month to get there. How do they get there? Farm tractors, huge farm tractors. Basically all converted to work in the Antarctic environment. They're really, really big. They bring their own kitchen with them, they bring their own living quarters with them, and they drag tons of fuel and other things with them too. They also have a plow in case they need to, which they do. This is the one with the living quarter and the kitchen. He is dragging that. I'm standing next to it. You can just see the size of these tractors. They are monsters. They are really monsters. Interestingly enough, there's crevasses in Antarctica where basically as these glaciers move, as this ice is moving all the time, sometimes it hits a different slope and they'll crack open. You'll get a crevasse, an opening in the snow, and it can go down hundreds of feet. Really dangerous, especially if they have snow over the top, so you can't see them before you get to them. So this first lead vehicle there has a ground-penetrating radar, and he watches that from in his cab and as they go along, and he's looking for crevasses under the snow. When they find them, they typically blow them up, and you can see the size of that hole. And apparently, sometimes they just climb down into them. I really don't know why, but they blow them up. I mentioned the South Pole moves at 33 feet a year. Some of these places on the plateau move 6 feet a day. So even if you're using GPS coordinates and know this is a safe way in, and it takes a month to get there, when you're coming back, it may be a completely different story. This is just a picture of their living quarters to give you an idea. This is how they now carry the fuel. Each one of those bags is 3,000 gallons of fuel. That is one tractor's load of fuel. So you have 1, 2, 3, 4, 5, 6. You have 18,000 gallons of fuel. While the LC-130s can bring in 3,000 gallons at a time, one tractor can bring in 18,000 gallons. You notice the ones on the left are a little bit depleted because it takes 2,600 gallons of fuel to get there. But there's more than one of these. They get drifts. They get really big drifts. So they do stop for the night. Sometimes when I wake up in the morning, they have a problem. The snow down there is not like snow here. You don't sink into it. As you can see, this guy's stepping on top of the fresh snow. It maybe sink in about 1/8 of an inch because it's so cold. The ice crystals stay ice crystals all the way down, and they pack very nicely in that wind. So they have to basically plow themselves out, and away they go on the road for another day to head there after their month trip. The Automatic Geophysical Observatory is where I work. I mentioned we take these, or maybe not mentioned, we take these twin-engine otters out there to get to them. This is, our first flight is from McMurdo to the South Pole Station. From there, we start traveling out to our AGOs, our Automatic Geophysical Observatories. We do them on a little twin-engine otters. They get about 2.5 miles a gallon. They fly at about 150 knots. They're not very fast. They don't get good gas mileage, but they can go through anything, and they're really, really reliable turboprops. So we load everything up, another very comfortable flight, and away we go. What I love is when you're flying over the plateau is just beautiful desolation. There is nothing. There's nothing as far as the eye can see. I mean, think about it. There's not even a rock. There's nothing. And it's just gorgeous, just seeing out to the horizon, nothing. But they only get 2.5 miles a gallon, and some of the places we go to are 500 miles away. So we have to stop for fuel. So we stop at a different cache. So the fuel caches along the way. Like so many things in Antarctica, I have a book over there. You can look at some of the nomenclature. They're usually named pretty strange. Roseanne Cache is Johnny Cash's daughter. There's also Johnny Cache. There's a couple other ones. Anything with cache in it, there's a fuel cache named after it. To get there, you basically dig up the 55-gallon fuel drums. They're dropped there on parachute by an LC-130 that was flying over. They put them on a pallet, drop them down. One of these planes will come in and get them all together, because obviously they're not all together, and bury them in the snow on their side with the bunghole, the opening on down, so they don't get any water in them. And we dig them up, pump them onto the plane, take our empties home with us, or actually out to the AGO with us, and away we go again. This is where I work. This is one of the AGOs. This is AGO 4. So finally you get to it. The building is the building on the right that's 8 by 8 by 16 feet. The other thing are our little caches. We have a fuel cache, a food cache, and an equipment cache. First thing we do is quickly unload the plane. Pilots usually come in for a few minutes into our little, there's our pilots, by the way, come into our little box there, and we give them some water or something like that, and away they go. They're gone. Now, we'll typically stay there for a week, sometimes longer. Longest that people have stayed there is 16 days after a week being done because the weather was bad and they couldn't get a plane in to get us out. I wasn't on that one, thank goodness. First things we do when we get there are melt ice because we need water. You dehydrate very fast, so very low humidity, as I mentioned. Also, you're very high altitude. Our highest station is 11,664 feet altitude. Pressure altitude well over 12,000 feet. Very dry, very cold. You need water. That's our instrumentation in the back. It's all, we've already taken off the blue board, which insulates it. we try to keep it warm. We try to keep it at 40 degrees below zero or warmer. In the winter, it'll get well below 100 degrees below zero there. So this is all our equipment that we're working on. Typically what we do when we go out there is, this is why I do engineering there, we'll fix things that are broken, bring new equipment that we've developed and built back in New Jersey and install it, and just basically take care of the station itself. Sometimes we'll set up an automatic weather station for University of Wisconsin. We will reorganize the caches, get them all cleaned up and organize, itemize what was there, and then away we go. Plane comes in again, you can see it in the background. By the way, these are powered by solar panels and wind turbines. Solar panels obviously work only in the summer. They're on the front and back of the building. The interesting part is the sun goes over your head every day, okay? And it's always at the same altitude, basically. It spirals over your head, just going around and around and around. There's so much reflectivity off the snow that the panels that are on the side opposite of where the sun is still get 80% of their power from the reflection. That wind turbine has 6-foot blades on it. We get a kilowatt of power out of that. And that can basically powers us through the dark winter, the whole winter. Again, just gorgeous. And you walk out of there and just take a look at where you are, and it is fantastic. It's like being on another planet. Anyhow, back to McMurdo. There we go. We're back. Now we flew back there, back on a plane, landed there, get another weird ride. These are Deltas. These are actually from the Navy. They're 1950s vintage. But now there's a problem. We have to go to Ego 5. Ego 5 we don't go to from the South Pole because it's too far away. It's about 800 miles. Too many fuel stops, too expensive, too long to get there. We fly from McMurdo to get there. But the idea is you have to be acclimated at altitude to go to the Ego. They won't let us go if you're not acclimated to the altitude. So typically what you do is you fly into McMurdo, get to the airport, get on another plane, and away you go. You're off to Ego 5. We got there. Weather was bad. We couldn't fly out. So now we're there for 5 days in bad weather. We're not acclimated to the altitude anymore. So now they have to make you acclimated to altitude. So how do they do that? Well, remember Erebus, the volcano? Basically, they put you on a helicopter, and they fly you up, and you set up camp on a volcano, which is really cool when you think about it. So this is Fang Ridge. You can see our tents there set up. Took a little walk away from there. And it's an active volcano. You can actually look over the edge of the sulfurous fumes and stuff coming out of it. And you stay there for about 4 days, and eventually they pick you up on a nice day where the weather is good, fly you back with the helicopter right to the airport, right on a plane, and go to the next one. So now we're at our next site. There's the tents we stay in. We set them up. You can sleep in those little Egos themselves, but typically what we do is sleep in tents. It gives you a little bit more privacy, obviously. But it's also pretty warm. I mean, it'd be 30 below, but 30 knot winds. But once you're in a tent, the sun's out all the time, so you feel pretty good. It's not bad at all. But you do have some spare time. I decided to fly a kite one day. I thought I was really special because I kept that kite up there for about a half hour until I had to go back to work. So I tied it to a shovel. I kind of forgot about it. The next morning it was still up in the air. It didn't need me at all. Eventually the plane comes back for you, picks you up, and away you go. This has come back into McMurdo. What you see there, that line, is the icebreaker. Now we're at the end of January, beginning of February. The icebreaker's coming in. It came in, actually. And that's where it comes through the ice, breaks down the ice. The icebreaker is called the Polar Star. It's the one icebreaker the United States has working right now. It can go at 6 knots, it's about 7.5 miles an hour, through 6-foot thick ice. That thing is powerful. It can break 21-foot ice, but it has to kind of lump up on it and go down. I talked to the people on it, and they said when they are breaking ice, no matter how tired you are, you do not sleep. It is so loud and so noisy and just so banging around all the time because you're banging into that ice all the time. But they make the path in there through the ice to get to the dock that I showed you in that first picture. And then the first cargo ship comes, and it's loaded, not unloaded. They unloaded it already. It's loaded with all the garbage that we make and all the junk that we have after a year. They have a really small window where they can come in with this stuff. Then a fuel tanker comes in. He fills up the rest of the 17 million gallons of fuel. They pump it in through pipes from there. Coast Guard ties up next to it. Basically now it's time for us to head home. Yet another weird vehicle. This one is just an amazingly big vehicle that you get into out to the airport. This time we got to fly out on a C-17, which is so much nicer than a C-130. First off, it's instead of 8.5 hours, it's only a 5-hour flight, which is beautiful. Second off, it's a lot less vibrating, and it's a lot more room inside. So a C-130 or C-17, even packed full, beats a C-130 any day. And if you ever wondered how the southern lights get turned on, this is how they do it. There is a switch. And with that, thank you very much for coming. I'll take any questions you have. I appreciate it that you're all here.
On the live stream, but let's take some questions here. Yeah, go ahead, Mark. Hold on, let me just do my my microphone thing here.
So they're in the part where it's like no sun. Do you still have the moon?
Yeah.
Moonlight?
Yep.
And everything? And the full moon, quarter moon, all
Yeah,
that
and
stuff?
all the same thing, yeah.
Okay, thank you.
Another question back here.
Yeah, why don't they make the welds out of the same metal that the pipe's made out of?
Well, the wells are just made out of the rod wells. They're just melted ice. The whole thing's made just ice. Oh, the pipeline. I think just welding material is different. You don't weld with steel, for example. You weld with welding rod. A welding rod is not just, it's not the same grade steel. So any kind of dissimilar metal, no matter what it is, you'll have a current between them.
All right, here you go. Another question.
What would happen if the atmosphere wasn't blocking the sun's rays?
Well, it's not the atmosphere. Well, the atmosphere is the one that protects us from ultraviolet rays. Without the atmosphere, we'd be basically cooked. That's why when you have a really sunny day. But if we didn't have the magnetic field, basically it would kill you. If we didn't have the magnetic field, we wouldn't be able to live here on Earth. It basically deflects most of the harmful radiation around us. It goes out into the magnetofield tail. Some comes into the cusps, into the North and South Pole, but not that much. And that's why I mentioned if you're an airplane pilot, there's a limitation for how many flights you take over the pole for that reason. We're not airplane pilots, and we're not there. Like airplane pilots may work 30, 40 years. We don't do that, so we don't have to worry about that as much.
So I have a question. At the magnetic South Pole, what does a compass do?
It spins around. It didn't, even during these solar storms, like during the Carrington event, the compass just went wild. They were just pointing all over the place. And the same thing happens at the magnetic pole, because you don't really have something far away pulling it, so you're kind of sitting over the top of it. It just wanders. It wanders.
Interesting. Okay. Any other questions here? We got one back here. Then we'll take some questions from the from online chat.
During one of your typical stays down there, how many times do you go out to an AGO?
Well, it depends. Usually about 3. We've been to 5 at one year, but typically we try to hit 3 in a year, 3 every year. You try to get to them because there's a lot that I didn't show you, but basically they have to be raised also. They get drifted in, and they get raised on those white poles that are on the corner with boat winches. Basically, we raise them up about 6-7 feet up higher than they are, redo all the guy wires that hold them, and then eventually they get drifted in. That's what happened to AGO 6. That's why it's so far down under the snow. Nobody got to it for years, and it's gone, absolutely gone.
All right. Yeah, we got some questions from the chat here. Actually, quite a few. So first, Stacy asks, why does the magnetic pole change, and what causes the flip?
I don't know, and I don't think anybody knows. They may. I know there's a lot of theories out there. The same with the sun. The sun flipping every 11 years. We really don't, not me, really don't understand the dynamics, exactly what causes that to happen. But it'd be really interesting to know. Especially, I'd like to know why the Earth one does more than anything else.
So next up is Philip. Actually, a couple of questions. First is it possible that we will see the aurora here with when the next big flare arrives?
Oh, definitely. If the KP index is above 7 here, you have a really, really good chance of seeing the aurora. Except if it's a night like tonight with the clouds out, obviously. but you really have a great chance. I mentioned I live in New Jersey, where KP has to be 8.5. Here it's you have a lot better chance than where I live. And there, since 1996, I've seen 2 aurora. Actually, one of our friends called up and said, "What's going on in the sky?" And I said, "Just a minute, I'll put the phone down." It was when we had a landline. I walked outside. It was an aurora. I just watched the whole thing through and came back in and saw the phone dangling there and realized I forgot all about Pat.
Yeah, actually, for those people that are here, if you go into our computer lab, there is a picture of it was October something or other in 2003, and it was an extraordinary solar storm, and you can actually see the aurora, and you can actually see all 3 of our domes in that picture. So if you haven't seen that,
Cool.
when we're done, we'll have to go and check that out. Hold on, we have a few more questions here.
And Philip followed up with, does the magnetic pole move?
Yes, it does. I mean, I actually have. I don't have it here. I'm not going to even try that again. Not that stupid. Anyhow, the magnetic pole does move. It actually has been the north magnetic pole and the south magnetic pole don't move exactly the same either. They're kind of offset in certain ways. And north magnetic pole has been moving faster, quicker than the south magnetic pole, but they do drift. South magnetic pole has moved quite a bit. It moved from where, very near McMurdo. I think that was in, I'm trying to remember the year, 1850. I may be way off on that. To where it is now, which is actually out in the ocean, off the continent completely.
All right. Then Stacy again asks, how do you get to go to McMurdo? Are there qualifications or any specific jobs that could get you there?
Yeah, well, I got there basically for working for the Center for Solar-Terrestrial Research, and I found out they went to the South Pole, and I said, boy, I'd like to go there. And a couple of years later, they said, would you like to go and work this year? Because we have work to do at Diego's. And I was just absolutely over the top with wanting to go. But as I mentioned when I showed you the picture of McMurdo, all the things that need to be done there, to a lesser degree, but still a lot of it at the South Pole. You need people to cook. You need, bakers. You need janitors. You need all that type of stuff. So if you take a look out on the web for jobs at the South Pole, you'll find quite a few of them covering everything you could think of, from a doctor to you name it. They're out there, a lot of jobs. So you don't have to be a scientist to work there.
Very good.
And by the way, summer has many more jobs than winter.
All right, and I believe this one was in regard to the discussion on water in Antarctica. What type of minerals do you need to replace there?
I don't know. I don't know. But basically, it's the same reason here. You wouldn't drink distilled water. If you do, you'll deplete the electrolytes in your body. Also, sometimes when you go to the hospital, they have to give you electrolytes for the same reason.
All right, and I think the final one, and this is from one of our regular viewers I was hoping would show up tonight. Their tag is only in Antarctica.
Oh.
So they ask, if a powerful CME did hit the Earth, is it realistic to say that a Faraday cage could protect a few emergency devices like an emergency radio or a laptop?
Yeah, that would definitely work. But the problem is, then what is going to power it? And the biggest problem is the transformers, because you can put a Faraday cage around them, but you have wires going in and out of them. Otherwise, you wouldn't have a transformer to begin with. So that's going to feed it right into it. But yeah, that definitely would protect them.
We do have another question. We have another question here on site. Your question?
So you said the Earth, it wobbled. So when the magnetic pole shifts, you said the axis moves, right?
The magnetic axis, yes. Not the Earth's axis.
Does that change the axis of its orbit?
No.
I mean, when it spins?
The Earth stays the same. It's just the magnetic pole moving. Think of it, bar magnet. I showed you a picture of bar magnet. Imagine a ball that was sitting still, and you had the bar magnet inside of it, and you moved the bar magnet, you twisted it. Okay. The magnetic pole is moving, but the Earth itself is staying in the same orientation the whole time.
And so when they shift, if the magnetic pole got to, say, a point along the middle of the Earth where the equator is, would compasses start pointing as north to that
Yeah,
section?
they would. And actually, it doesn't go as smooth. It gets very chaotic when it's in a process at 7,000 year time, approximately 7,000 year time it takes to shift. It's very chaotic, a little bit like the sun was, where you saw all magnetic field of aim in all different ways. It's not like a bar magnet anymore when it's changing. It's all sorts of, like having a whole bunch of different bar magnets in there, aim in different ways. But yeah, your compass would be going all over the place. You couldn't count on it anymore.
I apologize if you've asked this when I was sort of stepping out to see if we had any chance of doing any observing tonight, which unfortunately we don't. Is there a single time zone that everybody uses?
Yes, there is. Well, there's a bunch of time zones.
All time zones are there, but
Yeah, well, yeah, when you're at the South Pole, it's kind of neat. You can walk around the South Pole at about 5 foot distance from it and hit every time zone there is. And basically hit every latitude there is, too. But we typically, United States uses the New Zealand time zone. And that was picked because that's where we fly out of to get to our stations. So it made it a lot easier to coordinate, because time really has no meaning when you're down there. Certain things happen on time. For example, all the galley meals start at a certain time and end at a certain time, to the minute. But other than that, nothing happens on time. It just happens when it happens. Since you have 24 hours of daylight, it doesn't matter. Since you usually work on your own projects, if you want to work at 3 in the morning, fine, it's still sunlight. But anything official is New Zealand time zone.
and what kind of stuff do you do for fun?
Oh, lots of stuff. First off, I just love talking to people down there. You'll find scientists that are absolutely the top of their field. And
On the bottom of the earth.
on the bottom of the earth, on top of their field. But like here, if you ran into somebody that was a real top astrophysicist, say, you may introduce yourself and say hello and say a sentence or two to them. Down there, you sit down in the galley and you say, so what are you working on? What problems are you running into? And they'll talk to you for 2 hours. It's just very interesting, the people that you meet down there. And not just the people that are scientists, but even the people that come down there to work and do other things. I found a woman there that used to ride the rails all around the United States, and that's what she did before she went down there. Another one that was hula hoop champion. I mean, you just find weird things down there. But for fun, there's gyms, climbing walls. There's a lot of hiking trails, a lot of things you can do down there. It's just a lot of fun to be down there.
All right, we're going to wrap up with one more question from the chat. Gary asks, how can I purchase the South Pole clock?
I would love to have that clock. That clock is about 5 foot in diameter, by the way. But yeah, it's kind of a really cool clock with Antarctica in the middle and everything says north. But I don't know. I'd love to get one.
And I'm assuming they have internet down there, and that over time that has improved.
Internet stinks. At McMurdo, you have 24 hours a day internet. I mentioned from Black Island, where it comes over Black Island. It's very slow. You typically will have about 1.5 meg bandwidth shared between 900 people. Okay, so it's typically very slow. We had 3 different satellites. We hit DSCS. One of them is actually called Skynet, which I got a kick out of too. Nothing to do with Arnold Schwarzenegger, but it's actually called Skynet. And then TRDS, the 3 different satellites that we hit. South Pole's a different story. You do not have 24-hour-a-day satellite there. Basically, you get TRDS is the fast one. You get that for a couple hours a day. Skynet you get for a long hour a day, although they're phasing that one out completely. That one is very slow. I mean, I remote in every day because I have to do work. And I can hit a key and just sit there and watch, and all of a sudden, hey, shows up on the screen. I'm like, okay, got it. Very slow. And then the other one, TRDS. I can't remember which one, but one of them is also shared with the ISS. So although it's the high-speed one, it's 100 megabit.
TDRS?
TDRS, yeah.
TDRS, yeah.
It's 100 megabit, but chunks of it you only get it for a certain point during the day anyhow, and chunks of it are taken out when they dedicate it to ISS for data transfer.
Any other questions here? We do.
How do they know that the pole switches if it's every 7,000 years, or what's the
basically
evidence?
By looking at sediments in the ocean, going way down into that, and taking a look at the orientation of the magnetic fields in the different rocks and whatever down there, seeing how that changed. I always wonder how they know that stuff.
Well, unless we have anything else from the online, Gil, thank you so much. This was extraordinary. This hour and 40 minutes went by like that.
Well, I figured I could go really long today since it was cloudy, and I took advantage of it.
Sure. No, well, I very much appreciate it, and clearly, this is not for. But as a show of hands, who wants to go to Antarctica? Oh, actually, a couple of people. All right. All right. So, when you go down there, you have to promise to come back here and tell us what you did. Okay?
Does your beard keep you warm?
No, actually, I cut my beard off every year when I went down there, and then it would grow to about that length while I was down there because, why shave? And then one year my wife said, well, why you shave? Just let it grow. It keeps you warm a little bit. You get a lot of ice on it. But then once you get the ice on it, basically you have a layer of air underneath the ice that keeps your face warm.
I want to try something here. So can you just get out of this again? And we're gonna drag that whole. Actually, can we get to where actually see the file? Like, is it? Okay, so I'm gonna get out of that.
Minimize that or close that.
Yeah,
even.
go ahead and close it. And can we close this file too? For some reason.
Media. Oh, it's over here.
Yeah, get out of the full screen now. Let's see if I can do this now. Can I take this?
You can
Oh,
still-
okay. Oh, here. That's what I want to do. And I'm going to bring it over here. And
Oh, you can see it.
I know you can see it, I think.
Oh yeah, you're getting there. It's big.
And,
It's really big.
well, okay. That was so close. We're going to take this over to here.
It's really huge.
Yeah. And if I could just...
Shrink it down a
Yeah,
little bit. Drag it
try
on
to
down and shrink it down
yeah.
here.
Okay.
A little more.
A little bit more. Okay, we'll make
A
it.
lot more, probably.
Yeah. And let's see if I can take it over here. That's all right.
That's pretty good.
And as a matter of it, let me just try one thing. Yeah, there we go. So now we just need to get over here. Do you want to start it from the beginning? And you got this, Jeremy?
Yep.
All right. So we're going to just hit play and let's see what happens.
Attention all stations, stand by for severe weather condition announcement. McMurdo weather is set severe weather condition 1 for the following location. McMurdo Station, T-site, Arrival Heights, Davisfield, Williamsfield.
Check this out. This is the entryway to our dorm. Normally this has carpet on the ground and the walls are just normally walls, you know, but we're gonna open the door right now. It's a little bit like opening up the door to another world. Are you ready? It's a little bit blowy out there right now.
That's condition 1.
Attention all stations, stand by for severe weather condition announcement. McMurdo weather is set severe weather condition 1 for the following location.
If I click on this, then I don't know what will happen.
Oh, there you go. Yep.
I'll just show you what it's like in the bunkhouse here after
Black
the last
Island.
storm. All the snow you can see in the corner of the room here basically worked its way in through the tiny gaps in the window seals. The wind speeds got up to 222 miles an hour, so this filled up in just a matter of a few hours. And there's a complete lounge suite in the corner over there. This is a fireplace that's normally used for keeping the room warm. Now,
No place is safe.
Attention all stations, stand by for severe weather.
Okay. And just close it. Well, thanks for staying so long. I really went kind of long on that one. I knew I was going to. I had a shorter one in case it wasn't cloudy. But for those of you that want to go down there, definitely make it a goal. It's fantastic. It really is. It's an experience like no other in this world. Absolutely like no other.
We do have actually one more question, maybe to wrap things up. Let me bring it up here. So they ask, will Starlink ever be helpful? The SpaceX Starlink with
Yes,
connectivity
actually,
issues?
believe it or not, they're at McMurdo right now. They have one Starlink terminal up.
Awesome.
But one problem with Starlink is space weather comes in and it knocks their satellites down. They burn up in the atmosphere. But they have one terminal up. I assume that means I haven't been down there this year, but I assume that means they literally have one terminal working. But yeah, that is definitely great. Anything for communication is fantastic.
All right.
Because communication is so poor.
All right, well, thank you once again. I appreciate all you watching on the. We had almost at one point I think close to 40 people and watching online from some of our regulars and some newbies. And so thank you all for coming, and hopefully we'll see you next week. Thanks.
Thanks a lot for setting me up.